All right, let's dive right into this. Welcome to today's Explainer, where we're basically turning science into a game. We're putting everyday materials to the test in the ultimate metals versus nonmetals quick quiz challenge. I mean, have you ever actually stopped to wonder why your cooking pots are made of metal, but the handles you grab are usually plastic? Or think about a phone charger. Why is it copper wire on the inside, but totally covered in rubber on the outside? Well, if you're curious about that, you're in the right place. Get ready to think like a scientist. So let's kick things off by testing your observation skills right out of the gate. Take a look at this super busy market scene. It's totally packed with stuff we interact with every single day. I want you to scan this image just like a researcher would. What materials jump out at you? You're probably immediately spotting a lot of shiny, silver-colored objects stacked right in the center. But actually look a little closer at the edges of the photo and at the people too. You'll see totally different materials. Things like plastic bowls, woven fabric, and maybe even some wooden tool handles. Okay, here is your first official challenge. Can you list 5 objects right here in this photograph that are made of metal and 5 that are non-metals? Go ahead, really look. For the metals, well, it's pretty easy to spot those massive cooking pots, the heavy lids, and those big metal milk jugs just sitting there on the pavement. But what about the non-metals? Check out the woven baskets or those brightly colored plastic buckets scattered around the back. Even the fabric of the clothing everyone's wearing, or the wooden crates. It really just goes to show how completely surrounded we are by both types of materials at all times. Moving right along to section 1, the vocabulary cheat sheet. Because hey, before we get to the hard, rapid-fire questions, we definitely need to make sure we're speaking the exact same scientific language. Our very first vocabulary word is ductile. This basically means a material can be drawn out or stretched into a really thin wire. Imagine taking a thick lump of copper and just pulling it, stretching it like taffy until it becomes this long, thin string that you could literally use inside your phone's electronics. Now, try to imagine doing that with a wooden block or a chunk of rigid plastic. No way, right? It would just instantly snap in half. That amazing stretching superpower, that's ductility, and it's a totally classic trait of metals. Next up, we've got sonorous. A material is sonorous if it makes a deep, vibrating, ringing sound when you strike it. Just imagine taking a heavy wooden spoon and really whacking a metal frying pan. You get that loud, echoing ding, right? It rings out. Now imagine taking that exact same spoon and whacking a plastic storage container. You don't get a ring, you just get a dull, flat thud. That ringing ding is exactly what we're talking about when we say a material is sonorous. All right, now for malleable. This means a material can be bent, hammered, or pressed into a completely new shape without breaking or cracking at all. Think of an old-school blacksmith swinging a massive hammer onto a glowing hot piece of iron to shape a horseshoe. Metals basically yield to pressure. They bend instead of breaking. If you took a hammer to a rigid non-metal, like, say, a hard plastic block or a piece of chalk, it definitely wouldn't flatten out smoothly into a sheet. It would just immediately snap into pieces. And speaking of snapping, let's look at the exact opposite of malleable. Brittle. A brittle material shatters super easily when it's hit or bent. This brilliantly illustrates the point. Just look at the dry cereal in the bowl here. If you take a spoon and press down hard on a dry cornflake, it doesn't gracefully bend into a little cereal bowl shape, does it? Nope, it just crunches and shatters into a dozen tiny pieces. A lot of nonmetals are exactly like this dry cereal. They're highly brittle and super fragile under pressure. So let's put all of this together into our definitive comparison cheat sheet. You might want to lock this table into your memory for the rest of our quiz. Notice the stark physical differences here. Most metals are solid at room temperature, they're shiny, they absolutely do not shatter, they have super high melting points, and as we just learned, they are malleable, ductile, and sonorous. Plus, they conduct heat and electricity incredibly well. On the flip side, nonmetals, well, they can often be gases at room temp, they usually look pretty dull, they're brittle, and they are generally just very poor conductors. Now, some of these properties, like being shiny or brittle, we can figure out just by looking at or touching an object. Easy enough. But what about the invisible traits? We're going to set up a virtual lab test right now to check for electrical conductivity. Check out our setup. We have a cell, which is really just a battery, a lamp, and some crocodile clips all hooked up with wires, ready to go. If you were doing this investigation yourself in a middle school science lab, here are the exact steps you'd follow. First off, always check that the lamp is actually working by connecting the clips directly together. Next, you test your mystery material. Make sure you have good contact. If you clip onto a metal, boom, electricity flows right through it, completes the circuit, and the bulb lights up. But if you clip onto a nonmetal, like that rubber coating around a wire, it blocks the electricity entirely, and the bulb stays totally dark.
Okay, Section 2, the Rapid Fire Quiz Challenge. You've got the vocabulary down and you've seen the lab tests in action. Now it's time to see if you can truly think like a scientist. Get ready, here we go.
Question number 1 coming your way. Imagine you're examining a mystery material in the lab. You make a few notes. It looks dull, it is highly brittle when you press on it, and when you hook it up to your circuit test, the bulb stays completely dark. It does not conduct electricity. So, based on that, is this material a metal or a non-metal? Think back to those columns on our cheat sheet. If you said non-metal, you hit the nail on the head. Let's quickly compare it just to be totally sure. A non-metal is generally dull, brittle, and non-conducting. A metal, conversely, would be bright and shiny, malleable enough to bend, and highly conducting. Just by observing those basic physical properties, you solve the mystery. Piece of cake, right? All right, let's try question number 2. We know that the element mercury is officially classified as a metal, but what highly unusual property does it have? This is kind of a trick question because it requires you to remember that there are pretty much always exceptions to our cheat sheet rules in science. Think about what a typical metal looks and feels like when it's just sitting on a desk at room temperature.
Mercury completely breaks the mold here. It has an incredibly low melting point, which actually makes it a liquid at room temperature. It's wild. While almost all other metals, like iron, copper, aluminum, or gold, are solid and have extremely high melting points, mercury is a complete outlier. It perfectly demonstrates why scientists always have to be on the lookout for fascinating exceptions to the general rules.
Okay, here is your final rapid fire challenge. I want you to synthesize everything we've talked about today. Name 2 things that a metal can do better than a nonmetal. And don't just throw the raw vocabulary words back at me. I want you to really think about what those physical abilities actually let the metal do out there in the real world. So, what did you come up with? There are a few great winning answers here. You could have said they conduct electricity better, they conduct heat energy incredibly well, or they can bend without shattering. Meaning, of course, they are malleable. Now, what's so absolutely crucial about this slide is understanding how these exact properties literally build our world. Because metals conduct heat and don't shatter under pressure, we make cooking pans out of them instead of wood. Because they're ductile and conduct electricity, we make our internal power wires out of them rather than solid plastic. It all connects. Let's do a super quick review of our summary checklist to see how much ground we've covered in this explainer. First, can you distinguish between metals and nonmetals? Yes, using physical traits like shiny versus dull. Second, can you carry out investigations to distinguish them? Absolutely. We learned exactly how to build and use a conductivity circuit. And third, can you find relevant information to answer questions? You just crushed that rapid fire quiz, so that's a resounding yes. You have officially leveled up your science skills today. But you know, a really good scientist never actually stops asking questions. So I'm going to leave you with this final thought-provoking question to ponder. Of all the tests we talked about today, checking for shininess, seeing if it rings like a bell, trying to bend it without breaking it, or hooking it up to an electrical circuit, which test do you think is the absolute most useful to definitively distinguish between a metal and a nonmetal? Keep experimenting, keep observing the materials around you, and I'll catch you in the next explainer.